Alright guys, welcome to the last section of chapter 6, 6.8, cheapest link algorithm. So, our goal here, instead of starting and continuing on, we're actually going to piece together a Hamilton circuit by individual edges or links. We're going to try to choose the smallest or the cheapest weights first, which is where they get the name cheapest links. The lines they're going to consider links. So, step 1. We're going to pick the edge with the smallest weight first. So we're going to mark this edge or you can write it down, whatever. I prefer to highlight, so we're going to highlight as I go through the video here. But we want to find the smallest weight anywhere on the graph. So always look for your smallest number. Then step 2, we're going to continue this process. We're going to pick the next cheapest edge anywhere in the graph. Mark it or note it somewhere. We're going to continue to pick that cheapest available edge in the graph. Okay, we've got 3 conditions though that have to happen because we cannot close the circuit until we're completely finished. So we cannot close a circuit unless we're done. We cannot have more than 2 selected edges at any vertex. So if you're going to go and highlight a line and it's going to actually have 3 lines coming off of a vertex, you cannot choose that. Okay? And sometimes there may be ties in this one. Ties can be broken at random. Just don't break the rules. So if I've got 2 lines with the same weight and they're the smallest ones, and you could pick one or the other, just pick one. Okay? There's no right or wrong there, as long as you don't close a circuit and you don't have 3 lines coming out of a vertex. The last step is to connect the last 2 vertices to close that circuit. And then our final answer, of course, provide the weight, so add up all of the numbers that went along with it, and write the Hamilton circuit ordered from the vertex in the problem. So, let's go ahead and jump right into it. Example number 1. Okay. So what you want to do is you want to look at the graph and you want to find the smallest number possible on this graph. Anywhere in the graph. So let's see. It looks like our smallest number is going to be right here. 13. Okay. Now you want to go through and you want to find the next smallest number available. Okay, so it looks like it's going to be 15 here. Okay, I always like to highlight the line as well as the number so I can visually see what's going on here. Okay, our next smallest number looks like it's this number that connects D to E right here. Okay, the 20. Our next smallest number. Okay, here's where our problems come in. Our next smallest number is technically this 22 right here. But look what happens if I connect A to G. That closes off this circuit here. We've got a closed off circuit here. So that's a no-no. That's one of the ones that you have to skip. Remember, you cannot close off a circuit until you have everything. So if we skip over that one, it looks like our next smallest one is going to be 28. Okay, you've got 2 choices. I've got this 28 here from D to A, and I've got this 28 here, C to G. It just so happens that I can choose both of them. So that's what we're going to do. Okay. Our next smallest one looks like it's this line here that connects D to G. This line, hold on, let me switch colors here because I can't use this line, so just pay attention. D to G right here. Remember, if we go go back up and look at it for a second. Part B. Where it says the edge does not result in 3 selected edges at any vertex. Okay, if I were to highlight what I have in yellow right there, I've got 3 vertices that are coming off of D as well as 3 vertices that are coming off of G. So that's going to be a no-no. I cannot do that. Okay, so that's actually out. That is not an option. Okay. Our next smallest link looks like we've got 2 choices here. Okay, we've got a line that connects D to F, but we can't use that. Remember, no 3 lines coming off of D. You don't want 3 lines coming off of F. But we do have a 30 up here that connects C and B. Okay, how do you know you're done and you're ready to close off? If every vertex except for 2 of them have 2 lines coming off of them. So notice, C has 2 lines coming off of it, A has 2 lines, G has 2 lines, F has 2 lines, D has 2 lines. Every dot except for 2 have 2 lines coming off of them, which just means we need to connect these last 2 pieces together and be done. Okay, so write the Hamilton circuit from the starting vertex in the problem. So we want to start at G. So switch over to a marker here. G. G can go to F, and that had a weight of 13. F goes to A then, and F to A is 15. A goes to D then, so G to F to A to D, that is a weight of 28. D then goes to E with 20. E goes to B with 80. B goes to C with 30. I'm running out of room. And C goes back to G with 28. And finally, our last step is to add it all together. 13, 15, 28, 20, 80, 30, 28, 214. Okay, this next example, all they give us is a table. So, me being the visual person that I am, my suggestion to you is to, when you have a table only, I want you to draw the links to visualize the circuit. Okay, so let me see if I can find... I'm just going to draw it in. All right. Let's see if I can find a thicker. A, B, C, D, E, F, G. All right, A, B, C, D, E, F, and G. Okay, I'm still going to use the highlighter because I think it's easier. So, you want to look for, either pick the top part of the graph or the bottom part of the graph, whichever one you want to look at. Okay, so I'm going to go ahead and cross off this bottom part of the graph. I don't like to use it. Okay. All right. Go back to highlight. Okay, so in this top part of the graph, you want to find the smallest available number that you have. And that is this. Okay. And 13 connects G and F. So we've connected these two. Okay, our next smallest number up here looks like it's a 15. 15 connects F and A. See how you're building that visualization. So now you don't want to do anything with F because F already has 2 lines coming off of it. Okay, our next smallest number up here looks like 20, and that connects D and E. Your next available one connects A and G. Look what happens though if I would draw this line from A to G here. That closes off a circuit. We have a triangle here that connects A, F, and G. So we cannot do that one. Okay. So this is a no-no. We have to skip over that because that would close off a circuit here. Okay, continue on. 22, so my next smallest one is 28. Oh no, what happened? Sorry guys, give me a second. It looks like my stuff disappeared here. D. Everything shifted over somehow. I don't know what happened there. Oh, now I gotta find my thick marker again. D and E. Okay. We should be good now. Sorry about that. Okay, so 28. 28 here connects A and D. That's still doable. And I have a 28 here that connects G and C. We can do that too. Okay. Somehow we gotta get B connected in here. Let's see. Our next smallest one looks like this 30 here between B and C. Notice again, every one. This one has 2, 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 which means I need to close this off, so I need to connect B and E, which is that number right there. Okay. And then our last step is to write it out. We want to start at G. Okay. So I can go G to C. G to C is 28. From C we go to B. From C to B we're at 30. From B we go to E. E to B is 80. From E we go to D. E to D is 20. D to A. D to A is 28. From A to F, that's 15. And F back to G is 13. Add that up, we've got 28, 30. Oh, sorry guys, my battery's dying here. 30, 80, 20, 28, 15, and 13, to 14. Must be our magical number this chapter. Okay. Got 2 more examples to do with you guys. These are slightly smaller graphs, so not as bad. Okay. All right. Let's do green this time. All right. Example number 2. Our smallest link looks like it connects D and C. Okay. Our next smallest link looks like it connects E to A. Our next smallest link is 17 that connects E to C. Okay, we can't use this line that's 19 that connects A to D because it'll close off my circuit, but I can reach out to B here. And every point has been touched twice except for D and B, so we're going to go ahead and connect and use that number. So it looks like we're going B, oops, I keep forgetting to switch to a marker, B, and D, and C, and E, and A, and back to B. So we've got 29, 9, 17, 12, and 19. Okay. Let's add this up real fast. 29, 9, 17, 12, 19. Looks like we're looking at 86. Okay, last one. Again, if you need that visualization, go ahead and give yourself some points here so you can actually visualize what's happening as you connect. So that's A, B, C, D, and E. Okay. Let's do yellow. Okay, if we look at this, it looks like our smallest number up here is this 119. 119 connects A and C. Our next smallest number up here is this 120. 120 connects C and E. Our next smallest number is 121. But look what that connects. 121 connects C and B. If I draw a line from C, that gives me 3 lines coming out of C. So 121 is actually going to be a no-no. We can't use that number. Okay. Our next smallest number is 133 that connects A and E. If I connect A and E, what does that do? That'll close off a circuit. So that one is also a no-no. Okay. That's the problem with this method. This method has so many no-nos that it can cause complications unless you're really paying attention. So our next one looks like is 150 that connects B and D. That one's still good. Okay. 152 connects A and D. A and D is good. And then our last one, we've got to finish off our circuit here because every dot has been touched now and connected. So we're E and B. So that's 200. So we're looking at, we want to start at D. So D to A to C to E to B and back to D. So D to A is 152 plus A to C is 119 plus C to E is 120 plus E to B is 200 plus D to A to C, C to E, E to B. Finally, B to D is 150. Okay. 152, 119, 120, 200, 150. Gives me a grand total of 741. Okay, that's it for Chapter 6. Your homework tonight is on page 232, numbers 43 through 45, and number 47. Tomorrow you will review, and then you will test the next day. Have a good one.